Doug. Thank you for being here. Dipankar, thank you for being here. I want to get started with you, Doug. And I want to break down our first question into kind of three parts, because when we were talking, you used the term emulated human. So talk to us about what that actually means and how it compares to the AI that we know.
Yeah, so it's an interesting area that's coming up rapidly. And so we kind of coined the phrase emulated human because there's a lot of very technical terms underneath it that kind of drive it. But effectively, emulated human, which you can call computer use agents, computer use models, playwrights, et cetera, is a different way by which AI interacts with systems. So today, you have AI, and we have to kind of drill holes into your legacy systems, your current systems, build new API interfaces, et cetera, which gives us a lot of access into the back-end data. It takes a tremendous amount of time. Emulated human is exactly how it sounds. So you can really picture it as a self-driving car. And just like a self-driving car really learned how to drive a car by watching driving experts, emulated human is the same ability, to be able to interface with an existing system without having to drill holes into it and to be able to start to process work.
And then realistically, when can people start seeing it deployed within companies?
Yeah, so I would say it's moving rapidly. And Microsoft, Google, I sit on Google's AI Council, and so I kind of have a little bit of insights there. We also have a partnership with XAI where we're developing a lot of this. I can just tell you right now, we expect to have, while some things are already in production right now, there's still a ways to go. But we are moving very quickly. We've got 7 systems by which we are training these computer use agents today to be able to operate as efficiently or faster than what a human does today.
So, Doug, we know a major hurdle, certainly for folks in this room, for CIOs, is kind of the security risk of inline AI rewriting, right? Legacy systems. How do you think then the emulated human approach kind of bypasses those headaches?
Well, this is where it gets really interesting, because obviously, emulated human has a tremendous amount of value without having to modernize those legacy systems. But really, when you do that, when you drill those holes into those systems, they access raw data. And so all your data segmentation, your role-based security, everything else kind of goes by the wayside. Really emulated human, because it's logging in as the exact same way a human would, this exact same credentials, logging into the exact same systems, the same UI interfaces, everything else. All that controls, governance, and auditability that we've put in place for decades to kind of control the humans are now the exact same controls that will work to control these AI. So it's not really it's a different way of thinking about security. And what I think a lot of people miss about inline AI is they think about, well, I've got to develop a new API interface and all this kind of stuff. And what's happening now, if you start seeing the increases in governance and auditability and compliance requirements, et cetera, more and more questions are being asked about what is the risk profile around inline AI, because it's bypassing all these existing rules.
So Dipankar, Doug did a great job of setting us up. We know that one of the biggest fears with AI is sort of that black box, right? Hallucinates, makes mistakes, and then we're stuck. Since an emulated human now is taking actions on its own, how do you kind of keep an eye on it?
Yeah, look, the risk of hallucinations is real, as is the lack of transparency. But then we have to understand that the hallucination or the lack of transparency comes from the underneath reasoning model, and not what Doug explained as the emulated human that's actually sitting on top of the reasoning model. And hallucinations on the reasoning model, you can improve it by better quality data, with human in the loop, with retrieval augmented generation, and a variety of other things. As far as humans are concerned, a human agent, we are essentially kind of now splitting in terms of the decisioning versus the actual execution. So that's where the emulated human essentially is still confined to the same guardrails that an organization would put in terms of the credentials management, in terms of the navigation, in terms of if they get stuck, what kind of discretion can they apply? Certain discretion, even agents essentially can't really kind of do anything about, so they kind of escalate it to another layer. That's where essentially hallucinations, although at the reasoning layer, are essentially something that you can manage, and then the emulated human essentially sits on top. In practice, what actually happens is you intertwine the two. And once you intertwine the two, you actually have a model, or you actually have a system which learns over time, and then the hallucination essentially tones down. And then you have a highly effective system that comes up.
So Dipankar, I want to talk to you about adoption, right? Does emulated human then require rip it out, build a brand new infrastructure overhaul, or something else?
No, that's where I think it doesn't need any of the rip and replace of the underneath legacy system. In fact, that's one of the design principles that we actually follow, that it doesn't touch any of the legacy system because it doesn't have access. The emulated human doesn't have access to the APIs. It doesn't have access to the databases. It doesn't have access to the security controls and things like that. And that's where you don't actually need to create a new data pipeline. You don't need to kind of refactor applications. All that actually happens is the emulated human sits on top. And then there are separate projects that you can actually undertake. But then in terms of adoption, all that means is you could actually start seeing much more agentic, low agency use cases come into production much faster in terms of weeks and not months. There's a longer kind of an evolution that will happen on the underlying systems, legacy system modernization. But that's essentially something for much later, and then that's a choice in terms of a transformation with a capital T.
You used my favorite phrase, use case, and I have to ask you, can you walk me through an example of a use case, of an example in a complicated environment, maybe insurance or healthcare? What does it look like?
Yeah, I mean, for insurance, look, this is one of the most complicated workflows that we actually see in the industry because A, it's complicated, it's highly regulated, and you need a lot of compliance, you need auditability, and you need traceability. So if you look at insurance overall, think of it in terms of a claims adjuster, right? What would your best claims adjuster kind of do? So these guys, essentially, when a policy or a claim kind of comes in, they would log into the claim center. They would actually retrieve the policy. They would look at the exceptions. They would navigate through the exact same screens. And then if it's a straightforward claim, they would approve it. If it's not, then they would actually escalate it to the secondary line, where somebody would exercise discretion in terms of what really can be approved and so on and so forth. So an emulated human does exactly the same thing. It's just that you don't start doing it, but you observe how the human agent actually takes those decisions and not just what they do. And that's the learning part on the agentic aspect as well. And that's where you essentially have the notion of the insurance industry kind of adopting a high amount of agentic use cases on that side. So effectively, you have claims insurance companies kind of now looking at the simpler ones kind of completely autonomously being kind of executed. The more complex one, it will get escalated to a human, but you still actually have those kind of cases coming in. Yeah.
Great example, very interesting. Last question for both of you. Doug, I'm going to start with you. We've got a room of tech leaders here. What is the one thing you think that leadership teams need to be doing right now to kind of prepare themselves for this shift?
Well, I think, I mean, again, I think a lot of our clients are very focused on the inline AI because that's what everybody knows, right? And so emulated human is certainly not an or, it's really an and. And where do you apply it the most appropriately? And then kind of when does that come to fruition? So the good news around emulated human is really that there's really not a lot that you have to do to prepare for it. We're already trained it to work within your existing environments. I think it's more awareness. And so if you have a legacy application and you're looking at how to drill all those holes into the system and how much that's going to cost some time in terms of just dollars and then time, really you can start looking at emulated human as a potential other kind of pathway.
Dipankar?
I would think we need to just get started because, like Doug was mentioning, in terms of the model will actually develop, right? And with confidence scoring kind of coming in, these ones will essentially kind of improve over a period of time. But there are a plethora of use cases where you could actually put in the emulated human using the same controlled environment that a human would actually kind of have access to and automate entirety of a significant chunk of operations that you do today. And it's not just actually on the business operations side. You could think of it also in terms of the system integration business, what actually individuals do in terms of putting in actually configurability and kind of implementing enterprise applications. So the choice of actually things that you can do is immense. We just have to kind of get started and then assume that the underlying reasoning models will cope up with it.
Incredibly interesting and so much more to think about and talk about. I really appreciate you both being here. Thank you so much, Dipankar. Thank you so much, Doug.
Thank you.
Thanks for having us.